Hi everybody. This video is about how to find the determinant of a 2x2 matrix and also what the determinant represents. So let's go through how to find it first. It's a sort of an unusual looking calculation. So what you do first is you multiply across the main diagonal. So the determinant starts with 1 times -1. Then you subtract and you multiply across the opposite diagonal. So we multiply -5 times 5. Be really careful of the minus signs. Also, even though this looks really simple to do, and in a way it is, I think because of the layout of the numbers, you're looking along diagonals, it's really easy to make an arithmetic mistake. So especially when you're new to this, actually write it out and be very careful of the minus signs. So we multiply across the main diagonal, 1 times -1, which is -1. We multiply across the opposite diagonal, -5 times 5, well this is -25, but remember you're subtracting, so this is minus -25. So we have plus 25. So the determinant of this 2x2 matrix is 24. So fine, you can get the answers correct when you're asked about the determinant on a homework assignment or a test, but much more importantly is, what does the determinant mean? Well, the first thing that the determinant tells you is this. The determinant is an area scale factor. Now that just begs the question, what does that mean to be an area scale factor? You need to remember what a 2x2 matrix really represents. It's a way that you can represent a transformation. If you remember from a previous video, a 2x2 matrix takes a two-dimensional point and turns it into a different two-dimensional point. So it's a transformation. So let's imagine this. If we took this matrix, 1, -5, 5, -1, and we're interpreting this as a transformation, when you do matrix multiplication, so let's say I multiply by the matrix 1, 2, 3, 2, and 2, 5. Your interpretation of this matrix multiplication problem is as follows. Like I've already said, the 2x2 matrix itself represents a transformation. This 2x3 matrix, well, that represents a triangle because each column represents a point. So when you do this matrix multiplication, and I'm not going to do it or else the video would get way too long, but when you do this matrix multiplication, since it's 2x2 times 2x3, your answer is going to be another 2x3 matrix. And we won't do the multiplication, just imagine it. But since the product matrix is 2x3, our interpretation is that it's a triangle. And here's the first thing a determinant tells you. If you calculated the area of this triangle, so let me switch colors again. If you calculated the area of this triangle represented by the blue matrix, and you applied this transformation to it, the area of the green triangle would be the same thing, but it would be multiplied by 24. So you're scaling the area by a factor of 24. That's what this really weird number does. It tells you something about how this transformation works. In particular, it tells you how the transformation affects areas. So let's do another example. And I'll go a little bit quicker this time. So to do the calculation, multiply across, first multiply across the main diagonal. So we have 1 times 4. Multiply across the opposite diagonal, negative times negative, and we're subtracting. So it's minus negative 5 times negative 3. Again, be careful. Don't trick yourself thinking that you can just do it in your head, and you can once you're comfortable with it. Negative times negative is positive, but we're subtracting, so this is minus 15. So the determinant is negative 11. Now, with a negative determinant, we have another question, and that is, what does the negative mean? The 11, that's still an area scale factor. So if you applied this matrix transformation to a shape, the area would be multiplied by 11. But what does the negative mean? You can't multiply an area by a negative number. I mean, area is geometric. It's always positive. The negative, so the fact that the determinant can be positive or negative relates to orientation. So, what does that mean? Well, let me just tell you what it does. First, if the determinant is positive, then the shape is going to keep its orientation, and if the determinant is negative, the shape is going to reverse its orientation. So here's what that means. If we had a shape, let's say a triangle, and I'm going to call it A, B, C. If you applied a matrix transformation and it had a positive orientation, notice when I drew the triangle, I wrote the letters in clockwise order. If you trace your finger from A to B to C, your finger is going in a clockwise direction. If you keep the orientation, which is what a positive determinant will do, well, your triangle might look really weird. You know, it might look something like this. Maybe point A, you know, is now over here as A prime. But when you go from A prime to B prime, you're going to go clockwise again. So this transformed matrix, A prime to B prime to C prime, is still clockwise. Whereas in the example that we're currently doing, since the determinant is negative 11, the negative tells you that the shape is going to reverse its orientation. So whatever the triangle looks like, and again, the triangle can look really weird. Maybe A prime is here. Well, when you move your finger from A prime to B prime, you're going to trace this out counterclockwise because a negative determinant reverses the orientation. So as you go from A prime to B prime to C prime, your finger is moving in a counterclockwise fashion. So, the long story short about determinants. For a 2x2 matrix, the determinant is very easy to calculate, but it's a very important number because it tells you a couple of things about what your transformation is doing. Area scale factor and what it does to orientation. So that's what you need to know, and that's the end of this video. Hope it helped.